Hello friends, welcome back to another session of Core Java tutorials. In today's class, I'm going to show you TreeSet. So this is the collection hierarchy. So you can see that TreeSet is a class which implements NavigableSet, and NavigableSet is an interface which extends the SortedSet. And SortedSet is an interface which extends the set interface, and all these are there in java.util package. So TreeSet extends abstract set class and implements the navigable set interface. It creates a collection that uses a tree for storage, and objects are stored in sorted ascending order. Access and retrieval times are quite fast, which makes TreeSet an excellent choice when sorting large elements of sorted information that must be found quickly. TreeSet is a generic class that has its declaration as class TreeSet and E. So a tree set is a sorted collection that extends abstract set class and implements navigable set interface. So the properties of the tree set are the underlying data structure is a balanced tree, like it's a self-balancing binary search tree. Specifically, a red-black tree is the underlying data structure. The insertion order is not preserved. The elements are in sorted order. It sorts the elements in ascending order if they are numbers. If they are strings, then they are sorted according to the lexical order or alphabetical order. Duplicates are not allowed, and tree set and tree map are the two classes in the entire collection framework which support homogeneous collection only. So homogeneous collections are only allowed inside this tree set. And in case if we try to add a heterogeneous kind of object, then we'll be getting class cast exception is raised. Okay, if we try to take heterogeneous objects, null is allowed, but only once it is allowed. So unique elements are inserted or stored in this particular tree set, and it is not thread safe. So let us look into the constructors of the tree set. So these are the four constructors of the tree set. So the first form constructs an empty tree set that will be sorted in ascending order according to the natural sorting order of its elements. The second constructor builds a tree set that contains the elements of collection C. Okay. And the third form constructs an empty tree set that will be sorted according to the comparator specified by the comparator over here. Okay, constructs a new empty tree set sorted according to the specified comparator. If this comparator is not provided, so say for example, we don't want the natural sorting order. Then if we don't want the natural sorting order, we can provide a comparator. If we provide a comparator, the sorting will be based on that particular comparator. So the fourth form builds a tree set that contains the elements of the S. Okay, so these are the four constructors of the tree set. So let us look into some of the methods that can be applied on the tree set. Let us look into some of the methods that can be applied on the tree set. Okay, so the first one is add method. So then you have add all, then ceiling, clear, clone, comparator, contains, descending iterator, descending set, first, floor, headset with um, object, and then boolean inclusive, and then higher, is empty, iterator, last, lower, pole first, pole last, remove size, split iterator, then subset, tail set, and tail set. Okay, so these are the methods that can be applied on the tree set. So let us see each and every method in action now in program. Okay, let me show you how to create a tree set. Tree set is a generic class that has this declaration. So let me actually show you the declaration of the tree set. So this is how it looks. Class tree set, and it's a generic class. So here you will be mentioning the type of elements, objects that you want to insert into the tree set. Okay, so let us create a tree set. So I'm saying tree set, and let me say T is equal to new tree set. But I'm not mentioning the generic. I'm not telling what kind of elements go into the tree set. So it will depend on the element that I add first. Okay, so say first I'm inserting integers. So in case if I try to add other than integers, I'll be getting an exception. Okay, so first let me create a tree set and show you and print and show you. So herein I'm adding elements into the tree set. So then let me print the elements and show you. So I'm saying system.out.println and t. So first let us see what will be the output of this particular program. TreeSet is in the package, util package. So the first thing we need to do is import the package. So java.util.star. Okay. So now let me run this. Okay, so you can see I got 12, 34 and 56. Okay, so this is how the elements are inserted. Okay, so in the sorted order. So you can see, let me add one more element here. So which is 1. Okay, so you will be able to see the sorted order now. So I'll be getting 1, 12, 34 and 56. So this is a natural order. Since I didn't provided any comparator here in the constructor of the tree set, so it is giving me the elements in the natural sorted order. Okay, so I got 1, 12, 34 and 56. If I try to add an element, okay, so which is a double element, so I'm saying 67.89. So let us see what will be the answer we get. So you can see here, we got class cast exception because we try to insert an element which is other than integers. So as I said, homogeneous elements are only allowed over here. You can't add heterogeneous element because there is a comparison that is happening between the two elements. Okay, so even if I try to enter some alphabet, okay, so say I have entered a string A, even then we'll be getting class cast exception, okay, because I try to insert an element which is other than integers. So it depends on what exactly I am inserting. So say for example, I am removing all these integer ones and I just the first element that is inserted is a string. Now this tree set will take only strings in it. Okay. So now we won't be getting class cast exception because the first element, whatever we are inserting as first element, based on that only the tree will be constructed. Okay. So say I have h over here and then I said t dot add and then here say for example I have d. Okay, so now because these are strings, the natural order of sorting these strings is based on the alphabetical order or the lexical order. So I'll be getting a, d and h. Okay, so say for example I have mentioned the generics over here. Okay, so I'm saying I want the tree set to be constructed for integers. So I'm saying this tree set will be holding integer objects. So I specifically mentioned that over here. Okay. Now if I try to insert A into this particular tree set, okay, I'll show you what will happen. So you can see it is saying that incompatible types because string cannot be converted to an integer. I tried, I have set the generics for the tree that it will be holding only integer objects, but here I am trying to add a string. Okay, so this will not take the element in it. In here I have taken a tree set which will be holding integer objects and these are all the objects that I have put in the tree set and they are put in the natural sorting order of them which is 6, 10, 11 and 12. Okay, so let us try to apply some of the methods on this particular tree set. So first one is the add method which I already showed you. So let me also do one more method which is remove method. So remove method, so I'm applying the remove method and I need to pass the object that I want to remove. Say for example, I want to remove 6. So I'm saying remove 6. Okay. So after removing, let me try to print the tree set and show you. So this is how I have written the code. So you have seen 6 has been removed from the tree set. So this is the remove operation. So let me now show you how to do the contains operation to check whether an element is there inside the tree set or not. So contains checks whether the element is there in the tree set or not. So I'm saying t dot contains Okay, so T dot contains, and I need to know whether 13 is there in the tree set or not. So 13 is not there in the tree set, so this will give me a false. So you can see that I got false as an answer. So in case if I want to check the element that is already there in the list, 11 is there in the list. So contains will return a Boolean value. So when the object is there in the tree set, it will return true, else it will return false. So this is regarding the contains. So say for example, I want to clear off all the elements from the tree set. Okay. So I'll be saying T dot clear. Okay. So T dot clear will clear all the elements from the tree set. So the all the elements from the tree set will vanish off. Okay. So let me actually run this and show you. So this is before the clear operation. So before the clear operations, there were 4 objects in the tree set. After the clear operation, you can see there are it's an empty tree set. Okay. So the next one is the size operation. So let me actually apply the size over here. Size will give the number of elements that are there in the tree set. So I'm saying tree dot size. Okay, t dot size. Okay, so this will give me the count of number of elements in the tree set. So you can see the count is 4. Okay, so how many elements are there? So there are 4 elements in the tree set. So we got 4 here as the output. This is size operation. So let us actually do another operation, which is empty or not. So I'm saying t dot is empty. So is empty will return true if the tree set is empty, else it will return false. So in this case, there are elements inside the tree set, so I got false. Okay. So say for example, I apply the t dot clear operation and I'm trying to do the is empty operation. So now I'll be getting true. Because t dot clear operation will take off all the elements from the tree set. So now I'll be getting true. Okay, fine. So next I'll show you how to use the iterator. So iterator will extract the elements of the tree set one after the other. So I'm taking an iterator. So iterator t is equal to, so let me take I. Okay, iterator I is equal to t dot iterator. So this is the method iterator. So this is the method. So I'm turning in a while loop. So in here I'll say I dot has next. Okay, so this method will see check whether there are more elements or not. If there are more elements, it will return true, else it will return false, and the loop will break. So there are elements, so it will return true, and then so inside I am writing system dot out dot println, and then I'll be printing the elements of the tree set one after the other. Okay, so I'll say I dot next, and then I'll put some space over here between the elements. So let me actually run this. So you can see the elements of the tree set are extracted one after the other, 6, 10, 11, and the 12. So you also have one more iterator, which is descending iterator, which will actually print the elements in reverse order. So I'll just keep this while loop as it is, and let's take one more iterator, and this iterator, which is the descending iterator. Okay, so descending. Okay, so descending iterator. So this is the second kind of iterator, which will actually, let me make this as I1 because I already we have used. So this is I1. Okay. And now you will see that the elements are will be printed in descending order. So let me run this. Yes. Okay. So you can see the output there in these first 4 elements are printed using the iterator, which will be printing the elements in the order from left to right, how they are in the tree set. And this is where the elements are printed in the reverse order. Okay. So which is which uses the descending iterator method. Okay, I'll show you one more operation here. I'll try to empty the tree set using an iterator, removing the elements one after the other. Okay, so I have taken an iterator. So now what I'll do is I'll say t dot remove, and in here I'll say I want to remove I dot next. I want to take off the elements one after the other. And we'll see what will be the result of it, whether we'll be able to do it or not, we'll see. Okay. Yeah. So you can see you cannot remove the elements using an iterator. Okay. So if you try to make modification to the tree set after the iterator object is created, then you will be getting an exception which is called as concurrent modification exception. So you should not be modifying the tree set in the iterator. Okay. So once the iterator object is created. Now I will show you very important operations of the sorted set interface that have been implemented in the tree set. Those are the six methods specific to the sorted set are first, last, sorted set head set, sorted set tail set, and sorted set subset, and then you have comparator. Now coming to the first method, which returns the first element of the sorted set. So you can get the first element in the tree set, and last will return the last element of the tree set, and head set will return the sorted set whose elements are less than the object that we specify as argument. And tail set will give the returns the tree set elements which are greater than or equal to the object that we specified as an argument. And then the subset will be taking two arguments, obj1 and obj2, which returns the tree set elements which are greater than or equal to obj1 and less than obj2. So let us see all this in action. So I am taking off this iterator. Now I'll apply the first, last, and operations and so on. Okay. So let me take in system dot out dot println. Okay. So let me print the first. So I'm saying t dot first. Okay. So this will return the first element in the tree set. So the first element in the tree set is 6. Okay. So let me apply the last operation. So t dot last. So this will return the last element in the tree set. These are all the methods that are there in the sorted set which have been implemented in the tree set. Okay. So t dot last is giving the last element in the tree set. Okay. And then let us try to apply the operation which is head set. Okay. Okay. So which is tree dot head set. Okay. And in this head set, I am mentioning 11. Okay. So I'll be getting all the elements that are less than 11. So you can see I got all the elements that are less than 11. Okay. So this is the head set. Okay. Fine. So let me actually also show you what is tail set. Okay. And again, I have given 11 for the tail set. So you can see this is greater than or equal to. Okay. So tail set will give greater than or equal to. Okay. So head set will give only less than. Okay. So this is something we just need to remember. And then let us see what is meant by subset. Okay. So here in let me make it subset. Okay. So subset, and I want the subset of, let me insert two more elements, and then we'll try to do the subset operation. Okay. So let me add 15, and this will be 13. Okay. And I'll take off all this head set and all this. Okay. Let me keep the subset. We need to give two arguments. So I'm giving 6, and then so let me give 10. Okay. So 10 comma 13. Okay. So let us see the output. Okay. It's greater than or equal to 10 and then less than 13. Okay. So greater than or equal to 10. Okay. So that's why 10 is also included in the subset and less than 13. So I'll be getting only till 12. Okay. So this is regarding the subset operation. Now let us look into the comparable interface. Comparable interface is in java.lang package, and it has got only one method which is public in compare to. So this compare to method can be applied in such a way. So let me actually show you how we apply this compare to. So say for example, I want to compare A with P. Okay. So I'm saying compare. So it is there in the lang package, so we don't need to import the package. But for the tree set, we need to import the util package. So I'm saying java.util.store. Okay. So I said A compare to, and let me compare it with P. Okay. So I'm giving capital A and capital P, and let us see what will be the output. Yeah, you can see a negative value. Okay, so you can see a negative value. So this is considered to be obj1. So let me give you the syntax of it. So obj1 dot compare to, okay, and then I'll be giving obj2 here. Okay, so now obj1 is compared to obj2. So obj1 is the element that we are trying to insert. Okay, so obj1 is the one which we are trying to insert, and obj2 is the element that is already present in the preset. Okay, so that is already present is nothing but obj2. obj1 is the element that we are going to insert now. Okay, so when we compare obj1 with obj2, obj it returns a negative value if obj1 has to come before obj2. So if obj1 has to come before obj2, it will return a negative value because A comes before P. So that's why we got a negative value. Say for example, I'm giving P here and then I'm giving A here. Okay, so now we'll get a positive value. Okay, a positive value, we get a positive value if obj1 has to come after obj2. Okay, and it will return a 0 if both the values are same. Okay, so if both the values are same, obj1 and obj2 are same, then we will get a 0. So this is the natural sorting technique that is applied internally. So here I have entered 12, right? So when I try to enter let me actually show you this. Okay, so say for example, I want to insert 15. Okay, so 15, and the element that is already there is 12, right? So here it is 12. So when I do a comparison operation between 12 and 15, 15 has to come after 12. So I'll be getting a positive value. So you get a positive value if obj1 has to come after obj2. Okay, right. So this is how actually internally it compares. So I'm saying add and then I gave 11. Okay, so say for example the element that I want to insert is 11. So I'll be getting a, because it comes before, right? If it has to come before, okay, if it has to come before, we get a negative value. Okay, so we got a negative value. So 11 has to come before 12. Okay, so this is how actually internally your tree set works. So now when I print T, okay, so now when I print T, we can see that it will be giving it in the sorted order. So whenever we try to insert an element, internally this compare to method is called, and then based on the values, negative and positive values, the values will be put in the sorted order. So this is the natural sorting order that is present. But say for example, you want to customize the sorting order. So you don't want the natural sorting order, which is the ascending order. Say you want a descending order. So in that case, you have to use a comparator. So if you want to use our own sorting technique, we have to use the comparator interface. The comparator interface will give the elements in the customized sorting order. So this comparator is there in the java.util package. So it has got two methods. Okay, so this comparator has got two methods. The first one is the compare method, and the second one is the equals method. Okay, so the first one is the compare method and the next one is the equals method. So let me actually do that. So I'll be taking a tree set and then I'll do my own customized sorting technique on it and I'll show you. Okay. So let me actually insert strings into it. Okay, so names into it. So first one I inserted Sudha, and then I'll be inserting, okay, Anu, okay, and then I'll insert, okay, Prabhu, okay, and then I'll insert, okay, Ricky, okay. So these are the elements I inserted in the tree set. So let me actually run this. It will give the alphabetically sorted order. Okay, so the lexical order it will give. A comes first and then P and R and so that. So this is how we get. This is the natural sorting order. So say for example, I don't want this natural sorting order. So I have to write my own customized sorting technique. So to write that, so I need a class. Okay, so I'm saying my sort. Okay, so I need a sort. So I'm saying my sort, which need to implement, okay, the comparator. Okay, so the comparator class, comparator interface. And inside this comparator interface, I said there are two methods, right? The first one is the compare method and the second one is equals method. No need to override the equals method. That is provided by your JDK itself. So generally in the methods in the interface need to be implemented in the class, but here equals method you no need to implement. Okay, so I have to implement the compare method. So the compare method will be taking two objects. Okay, so the first one is obj1 and the second one is obj2. Okay, so because it has to compare between these two objects. So I'll be taking the first one in string. Okay, so because these are strings, I have stored strings in the tree set. So I'm saying string s1 is equal to obj1 dot. I need to convert it into string, right? So obj dot to string, and then I have one more string which is s2 is equal to obj 2 dot. Let me show you another way of typecasting it. So I'm saying string and then I said obj2. Okay. So these two objects we have taken in S1 and the S2. Now let us try to compare them. Okay. So to compare them, so I'm simply saying written. Okay. And then I the I'm saying S2 dot compare to. Okay. S2 dot compare to, then I'm saying S1. Okay, so S2 dot compare to S1. So this is what I have done. I'll tell you the logic, what I have applied. So before that, what I need to do is, so I have taken a tree set, but here I am passing my own sorting technique. So I need to take the constructor, which will be taking the comparator of reference. Okay, so I'm saying new my sort. Okay. So I'm passing in this particular sort into this particular tree set. So now the natural sorting technique will not be applied. So this sort that I have put in the compare method will be applied. So I said this one. Okay. So let me actually run this and show you. So you'll be able to see that the elements will be sorted in the reverse order. Okay. So because I have provided this. The comparison will happen like this. So I want to insert Anu, right? So Anu dot compare to, and now it will make comparison with the Shiva. Okay. So it will be comparison like this. So let me actually put this in system dot out dot println. Okay. So this is how the comparison happens. So you can see you got a negative value. Okay, so whenever you get a negative value, it means that Anu has to come, obj1 has to come before this one. Okay, but if I reverse this, okay, say for example, I'm giving Sudha here and then I'm putting Anu here. So now what will happen? I'll get a positive value. Okay, so when I get a positive value, it means that it has to go after this. Okay, let me also show you what are there in S1 and S2. Okay, so this is S1. This is S2. Okay, so when I run this, okay, so you can see here that S1 is Sudha initially, S2 is Sudha. Just take a look at the order in which I have inserted. So then I have inserted Anu. So Anu is S1, okay, and S2 is Sudha. So what it is doing, it is saying Sudha dot, okay, Sudha dot compare to Anu. Okay, so this is what is applied. When Sudha dot compare to Anu is performed, so we saw that it is returning a positive value. When it is returning a positive value, it means that obj1 has to come after obj2. Obj1 is obj1 is Anu. Anu has to come after Sudha. Okay, so this is what we have done. We have reversed the logic. So it will return a positive value. Whenever a positive value is there, obj1 and obj2 are compared, and when the positive value is written, obj1 has to come after obj2. So here obj1 is nothing but Anu, obj2 is Sudha. So we are saying Anu has to come after Sudha. Okay, so that is the logic we have applied here. But in case if I put S1 compared to S2, then it will do the natural sorting itself. Okay, so you can just take an observation here. It will do the natural sorting itself. So you don't want the natural sorting. So what you are doing here is, here I am comparing S2 with the S1. So it depends on what is the value it is returning. If it returns a positive value, then obj1 has to come after obj2. If it is returning a negative value, obj1 has to come before obj2. So we are just using that simple logic and manipulating the order of the elements in the tree set. Okay, so this is how actually we do the custom sorting. We apply the custom sorting in the tree set. I hope this video is helpful to you. Thank you for watching.